Hey guys, welcome again to the Maths Club. If you are just joining us, welcome. In this video, we're going to be looking at WAEC past question on total surface area and volume from 2014 to 2023. If you have been following this particular series, you see that we've been treating different kind of shapes how to find total surface area and volume, and the WAEC past question video is always capping all of them up. So if you have not watched any of them, I encourage you to start from there. Also, if you're not subscribed to our channel, please do. And if you know someone that this channel can be helpful to, please share the word. I would advise you to go ahead and like the video because you would definitely enjoy it. And if you have any question, drop it as a comment. We'll treat all questions as soon as possible. Let's get started. Question 1 says that the radius and height of a solid cylinder are 8 cm and 14 cm respectively. Find correct to 2 decimal places total surface area. Take pi to be 20/7. This take from June 2023. As always, I would encourage that you pause the video and try it out yourself before you see how I would solve it. So we have this. What are we given? We're told that the radius is 8 cm and the height is 14 cm. So for the total surface area of a cylinder, right, this is one surface and that surface, so that is pi r squared plus pi r squared, which is 2 pi r squared, plus we've already talked about that the curved surface area of a cylinder is 2 pi r h, right? Remember that video where we spread it out and we tried to find what the formula is. So if I factor out 2 pi r from both sides, that will work. So that will be 2 pi r squared divided by 2 pi r will leave me with r, plus 2 pi r h divided by 2 pi r will leave me with h. Now we can substitute. So this is, let me just say, is equal to 2 times 22/7 times the r is 8, open brackets, 8 plus 14. So that will be 2 times 22/7 times 8 times 8 plus 14 is also 22. So you take a calculator and punch this. 2 times 22 times 8 times 22 divided by 7. This will give you 1106.2857. right, the centimeter squared, because it's a surface area. But they said we should correct to 2 decimal places. So this decimal place, 1 decimal place, 2. The next decimal number is 5, right? 5 and above, right? This is 5, and of course it's 5 and above, so that will carry over 1. So that will be approximately 1106.29 centimeter squared to 2 decimal places. Let's see which of our options this will align with. That is option B. Great. Question 2 states that a sphere has a radius 3 cm. Find in terms of pi its volume. This is from June 2023. So we have our sphere here, right? What are we given? We're told that the radius is 3 cm and we should find the volume. So the formula for volume of a sphere is what? Can you remember? Great. So 4/3 pi r cube. And that is 4/3 because we're leaving our answer in terms of pi, so that is times pi times 3 cube. One of these will cancel one of these, so it remains 2. So 3 squared is 9. 9 times 4 is 36. So our answer is 36 pi centimeter cube. Right, that's the volume in terms of pi. Let's see if our answer is correct. That will be option C. Great. Question 3 now says that an empty cylindrical tank is 140 cm in diameter. If 200 liters of water was poured into the tank, calculate, correct to the nearest centimeters, the height of the water in the tank. Take pi to be 20/7. This take it from June 2023. As always, I encourage you to pause the video and try it out yourself before you look at how I will solve it. So what are we given? We're told the diameter is 140 cm. So we can reduce that the radius is d/2, which is 140/2, and that will give you 70 cm, right? Great. It now says if the volume of, if 200 liters of water was poured into the, that means the volume is basically 200 liters. Let's convert this to centimeter cube, right? So because it's correct to the nearest centimeter, we know that 1 liter is 1000 centimeter cube. So 200 liters would be x centimeter cube. If you cross multiply, your x is 200,000 centimeter cube. So our volume is also equal to 200,000 centimeter cube. It now says that we should find the height, which is h. So for a cylinder, we know that the volume is what? Great, pi r square h, right? So that is 22 over 7 times the r is 70, so that will be 70 all square times h, and this volume was given to be 200,000. So let's simplify. 200,000 is equal to 22 times 70 squared divided by 7, so this is 15,400 each. So if I divide both sides by 15,400, let's see what that will give us. So 200,000 divided by the answer, that will give me my h to be 12.987 centimeter. But the question says that we should correct to the nearest centimeter. So this is nearest centimeter. The next value after it is greater than 5 or equal to 5. Right? The trick is greater than or equal to 5. This is 9. So I'll carry over 1 to this guy. So that will be my h is approximately 13 centimeter. Let's see which of our options will align with that. That will be option C. Great. Question 4 says that a cylinder opened at one end has a radius of 3.5 centimeter and height of 8 centimeter. Calculate the total surface area. This is taken from June 2022. So we need to note something. It said it's open at one end, so this part here is probably closed and this part here is open. Right? So what are we given? We're told that the radius is 3.5 centimeter and the height is 8 centimeters. So what is the total surface area? So in this case here, since this place is open, we are not including that area there. It's just be one of the circles or the circular bottoms, one of the bottoms, right? So that will be for this. Okay, this is meant to be question mark. Total surface area will just be one of them, which is pi r square plus the area of the surrounding body, which we have discussed to be 2 pi r each. So we can factor out pi r from this, and this will give us r plus 2h, and that will be 22 over 7 times the radius is 3.5 times open bracket 3.5 plus 2 times 8. That will be 22 over 7 times 3.5 times this is 16, right? So 16 plus 3.5, that will give you 19.5. So let's plug that into the calculator. 22 times 3.5 times 19.5 divided by 7, that gave me 214.5 centimeter squared. So this should be our answer for this question. That will be option D. Great. Example 5 says that we should find and correct to 2 decimal places the volume of a sphere whose radius is 3 centimeter. Take pi to 22 over 7. This is from June 2022. The same is one of the questions that we solved before, but that one itself should express the volume in terms of pi, if I recall correctly. So the volume of a sphere, we've said that to be 4 over 3 pi r cubed. But what are we given? We're given the radius to be 3 centimeter. We're given pi to be 22 over 7, right? So that is 4 over 3 times 22 over 7 times 3 cubed. One of these will go, so it will remain 1 squared, right? So that will be 4 times 22 times 9 divided by 7. This gave the answer to be 113.142, let me just say 9 centimeter cube. But they said we should correct to 2 decimal places, so this would be approximately 113.1. The next guy here after this guy is less than 5, right? So I mean, it's not going to carry over anything, so that will be 113.14 centimeter cube. Let's see if answer is correct. So that is option D. Great. Question 6 now says that find the volume of a cone of radius 3.5 centimeter and vertical height 12 centimeter. Take pi to 20 over 7. Take from June 2022. So what are we given? We're given the radius to be 3.5 centimeter. We're given the height to be 12 centimeter. We're given pi to be 22 over 7. So remember that trick I told you, that is like 1/3 of a cylinder, right? So the volume of a cone is 1/3 of the volume of a cylinder, so that's times pi r square h, right? So 1 over 3 times 22 over 7 times 3.5 all squared times 12. let's see, this is 1 over 3. Okay, 3 can go here. This is 4, so we need to carry over that 1 over 3 everywhere. So this is 22 over 7 times 3.5 all squared will give you 12.25 times 4. So times 22 times 4 divided by 7, this give me 154 centimeter cube. That will be option D. Great. Question 7 asks that the diameter of a cylinder closed at both ends is 7 centimeter. If the total surface area is 209 centimeters squared, calculate the height. Take pi to be 20 over 7. Take from June 2022. So what are we given? We are given the diameter to be 7 centimeters. So that means the radius is 7 over 2 centimeters, because that is what D over 2. So I told the total surface area is 209 centimeters squared, and we should find the height. But I told pi to be 22 over 7 and to find the height. So because it's closed at both ends, the total surface area here would be pi r squared plus pi r squared, which is 2 pi r squared, plus curved surface area, which is 2 pi r h. Factor out 2 pi r from them, that will give you r plus h. Then substitute, that will be 2 times 22 over 7 times 7 over 2 times 7 over 2 plus h. So 2 will cancel this, this will cancel this. We're left with 22 open bracket 7 over 2 plus h. Right, but I thought the total surface area is 209, so that will be 209 is equal to this guy. So 209 will be equal to, by the time I open the brackets, 2 divide 22, that will give me 11. 11 times 7, that will give me 77 plus 22h. So 22h will now be equal to 209 minus 77. So 209 minus 77, that will give 132. So 22h is equal to 132, and divided by 22, that gave me 6. So our h is equal to 6 centimeter. Let's see if our answer is correct. Great. Question 8 now says that a cone with perpendicular height 24 centimeter has a volume of 1200 centimeter cube. Find the volume of a cone with same base radius and height 84 centimeter. Take pi to be 20 over 7. Take from June 2022. So what are we given? We're given 2 cones. So cone 1 and cone 2. For cone 1, the height is 24 centimeter. The volume is 1200 centimeter cube. Right? For cone 2, we're trying to find the volume. Okay, this one has a radius, right? Which we don't know yet. And they said it has the same radius as this guy, so the radius is also equal to r, but the height is 84 centimeter. And we're told to take pi to be 22 over 7. So for cone 1, we know that volume is 1 over 3 pi r square h, right? You should know that at the back of your finger now. That will be 1200 is equal to 1 over 3 times 22 over 7 times r squared times the height is 24. So 3 here 1, 3 here 8. So that will be 1200 is equal to 22 times 8, which will give you 176 r squared divided by 7. So if I cross multiply, that will be 176 r squared is equal to 1200 times 7. So 1200 times 7 divided by 176, that gave me my r squared to be 47.73 centimeters squared. So if I take square roots of both sides, my r will be equal to, if I take square root of that, that will give me 6.90849, basically 5. So if we say that, what I've started doing now is that if I'm working with something that is not the end result and I have to approximate, try to leave it in like 3 or 4 decimal places so that your answer will be closer to the real answer. I could have said 6.91 here, but that would be too much of an approximation. So given that, so for C2, we can now find the volume, which is 1 over 3 pi r square h is 1 over 3 times 22 over 7 times 6.9085 squared times the h. What is the h? 84. So 84 divided by 7, that will give you 12. So this is 12, this is 4. So the volume is 22 times 6.9085 all squared multiplying 4. That will give you 4,200 centimeter cube as the volume. So you see, this is the answer to this particular question. Let's see if it's correct. Great. Question 9 now says that a cone has a base radius of 8 cm and height of 11 cm. Calculate to and correct to 2 decimal places the curved surface area. Take pi to be 22/7. This is from June 2021. So for this cone here, let's just say it has a perpendicular height of 11 cm and the radius is 8 cm. So we're trying to find the curved surface area. That is pi RL, where L is the slant radius, right? So we can fish out this guy. I said this is 8 cm, this is 11 cm, this is the right angle, find x. So from Pythagoras, I'm going this fast because we have treated almost all these things before in all of the previous videos. The hypotenuse squared is equal to the opposite squared plus the adjacent squared. So that will be 11 squared plus 8 squared. That will be 121 plus 64, and that will be 185 centimeter squared, right? So the hypotenuse will just be square root of 185 centimeter squared. That gave me 13.60147 or 6015 centimeters. That's our hypotenuse, which is our L, right? So the curved surface area would now be 22/7 times 8 times 13.6015. So 22 times 8 times 13.6015 divided by 7. This will give you 341.98. Okay, they said correct this, but let me just write it down. So 06 centimeters squared. So to 2 decimal places, so this is approximately 341.98. After it's 0 is not even up to 5, so that will be 0.98 centimeters squared. So 341.98 centimeters squared. That will be option A. Great. Question 10 now says that a solid brass cube is melted and recast to a solid cone of height h and base radius r. If the height of the cube is h, find r in terms of h. You can read it again, pause the video until you understand the particular question and you can solve it. But let's take it from June 2021. So you have a solid cube, you melted it to form a cone. The volume of the cube in terms of value will also be the volume of the cone. That's one thing you need to know. So if we are given for the cone that the h is h, the r is r, and then for the cube the h of the cube is h, then find r in terms of h. Great. So like I said, the volume of the cube is equal to the volume of the cone. So for the volume of the cube, one side of the cube, the length is the same as the height, right? Because all the sides are equal. That's a good thing about cube. So the volume is L cube, but here we can say h cube is equal to 1/3 pi r square h. The height of the cone is the same as the height of the cube, so we're good. This will cancel off the h cube to remain h squared. So that will be h squared is equal to pi r square all over 3. If I cross multiply, that will be 3h squared is equal to pi r squared. And if I divide both sides by pi, this will give me r squared is equal to 3h squared all over pi. And if I take the square roots of both sides, great, so that will be r is equal to square root of 3h squared all over pi. H squared, I can take the square root of that, right, and bring it outside. That will be r is equal to h square root of 3 over pi. I've taken the square root of this guy and I've brought it outside. So this is our r in terms of h. That was h square root of 3 over pi centimeter. Let's see if we're correct. That will be option D. Great. Question 11 says that the dimension of rectangular base of a right pyramid is 9 cm by 5 cm. If the volume of the pyramid is 105 cm cube, how high is the pyramid? This is from June 2020. So the first thing that we're going to know is what are we given? For the base, which is a rectangle, the first guy is the length, so the length is 9 centimeter, right? The width of the base is 5 centimeter. The volume of the pyramid is 105 centimeter cube, and I also find the height. So for the volume of a pyramid, remember when it's something like this, right, like cone, like pyramid, there is like this rectangular shape at the top, right? Always know your 1/3. That's key. So 1/3 of the base area multiplying the height. So where's the base area? The base area is this rectangle. So the base area of rectangle is length times breadth or width, which is 9 times 5, which is 45 centimeter cube. So let's now substitute. So this 105 is equal to 1/3 times 45 times h. 3 here 1, 3 here 15. So 105 is equal to 15h, and if we divide both sides by 15, so 105 divided by 15, this will give you 7. So that means the height here is 7 centimeter. That is how high the pyramid is. Let's see if our answer is correct. That will be option D. Great. Question 12 says that the diameter of a sphere is 12 centimeter. Calculate, correct to the nearest centimeter cube, the volume of the sphere. Take pi to be 22/7 and take from June 2020. So what are we given? We're told the diameter is equal to 12 centimeters. So that means we can find the radius, right? So radius is d/2, which is 12/2, which is 6 centimeter. And we're told that we should find the volume, but we're told pi to be 22/7, and the volume E is missing. So how do we find the volume of a sphere? Remember, there's sphere, there's hemisphere. Great. 4/3 pi r cube. So this is 4/3 times 22/7 times the r in this case is 6, so 6 raised to the power of 3. Right? Let's not overstretch anything. What's a 6 cube? That's 36 times 6, and that will give you 216. So 216. 3 can go here, 3 can go here, 72. So now let's simplify. 4 times 22 times 72 divided by 7. This will give you 905.14285, which is 29 centimeter cube. But the question is that we should correct to the nearest centimeter cube. That is approximately, after this guy, what we have here is 1. 1 is less than 5, so it's not going to carry over in it. So that's approximately 905 centimeter cube. Let's see if our answer is correct. That will be option C. Great. Question 13 says that a solid cuboid has length 7 centimeter, width 5 centimeter, and height 4 centimeter. Calculate total surface area. This is from June 2020. So these are cuboid. What are we given? We're told the length is 7 centimeter, the width is 5 centimeter, the height is 4 centimeter. We're told to find the total surface area. For total surface area, remember, we will see, if you remember what we did, that we talked about how we got the formula, so I'm not going to just stop ourselves by doing that again. That will be 2 open brackets, LW plus LH plus WH, right? So this will be 2 open brackets. The L is 7, so that's 7 times 5, plus the L is 7, the H is 4, so that's 7 times 4. The width is 5, the H is 4, plus 5 times 4. This is 2 open brackets, 35 plus 28 plus 20. So you take a calculator, that will be 35 plus 28 plus 20, and this is 83. So this 2 times 83. So multiplying this by 2, this gives you 166 centimeter squared. So this total surface area of this cuboid. Let's see if we're correct. That will be option B. Question 14 says that the ratio of the radius to the slant height of a right circular cone is 2:5. You can pause video and let that sink in. If the total surface area of the cone is 224 pi centimeter squared, calculate the slant height and the volume of the cone. Take pi to be 22/7. This is from June 2020. So imagine this is our cone. Let me draw this down, this down, this down, this down, and like this, right? So the ratio of the radius to the, I told you, whenever you see ratio, don't say it is 2, just say 2x. Then the slant height, right? This is the slant height, this guy here, let's say this is 5x. Great. So now says if the total surface area of the cone is 224 pi centimeter squared, calculate the slant height. So what are we given? We are given the radius r. I'll just say 2x because this is the ratio. We're given the slant height L as 5x. Or given the total surface area as 224 pi centimeter squared, right? I want us to find the slant height L, right, the real value, and the volume. Great. So for total surface area of a cone, right, we will see the area of the bottom, which is like the area of a circle, which is pi r squared, plus the curved surface area, this guy here, is curved all around, so that's pi r l, right? So let's simplify. That would be, I can factor out pi r from both of them. Pi r squared divided by pi r will remain r, plus pi r l divided by pi r will remain l. So these are TSC. So our TSC is 224 pi will be equal to pi, the r is 2x, so times 2x, open bracket, r is 2x plus l is 5x, right? So this 224 pi is equal to 2x pi multiplying 7x, right? So that will be 224 pi is equal to 2 times 7, that's 14, x times x, that's x squared, and then our pi. Great. So if I want to make the x squared stand alone, I'll divide both sides by 14 pi. So this 14 pi, pi will cancel pi, and 224 divided by 14 will give you 16. So this will cancel this. So your x squared is equal to 16, right? So therefore our x is equal to 4 if I take the square root of both sides, right? So therefore our L is 5x, so therefore L, which is equal to 5x, would now be equal to 5 times 4, which is 20 centimeter, right? And then for the B part, so this is the A, the volume of a cone is what? Remember, 1/3 of pi r square h, right? So we need to find r. R is, what do we say r is? R is 2x, right? So let's substitute. R is 2x, which will be 2 times 4, which is 8 centimeter. Do we know the height? We don't know the height yet, so but we know the r and the l. So we know from Pythagoras, if this is the l, this is the r, this is the h, we could say l squared is equal to r squared plus h squared. This is h squared plus h squared, and this is 20 squared. So this 400 is equal to 64 plus h squared. So h squared would now be 400 minus 64. So 400 minus 64, that will give you 336. So our h squared is equal to 336. Then our h is equal to square root of 336 centimeter. Let's leave it at that. So we know our r, we know our h. We can find our volume by saying therefore v is equal to 1 over 3 times 22 over 7 times r is 8, which is 8 squared, times square root of 336. So let's simplify this. This would be is equal to 1 over 3 times 22 over 7 times 64 times square root of 336. I want to leave it as square root of 336 so that there will not be any approximation issues. That will be 22 times 64 times square root of 336 divided by 3 divided by 7. So this gives me 1229.00, so 1229 centimeter cube. Is that what they said we should do? So calculate this. Okay, great, we're good. So our slant length is 20 centimeters and our volume is 1229 centimeter cube. Let's see if we're correct. Great. Question 15 says that diagram shows a wooden structure in the form of a cone mounted on an hemispherical base. The vertical height of the cone is 48 meters and the base radius is 14 meters. Calculate, correct to 3 significant figures, the surface area of the structure. Take pi to 20/7. Let's take from June 2020. You can pause the video, read the question as many times as you need, and solve it. So look at this. What's thing that we know, if the radius is 14, then that means that this height here is also 14. So this place here is also 14 because those are the same radius, and that means total height here is going to be 60. For an hemisphere, the surface area of an hemisphere usually is the surface area of the curved section plus the surface area of the circular base. You know, when you cut that sphere into two, if you look at the base or the top, depending on how you're looking at it, there will be a circular base. So the curved surface of the sphere, if you look back at what we did, is 2 pi r squared. Then the curved surface area of the circular portion on top is pi r squared. So we'll say pi r squared plus 2 pi r squared, right? But in this case, that circular portion at the top has already been covered by the cone that was mounted on it. So of course that pi r squared is not going to show, it's just going to be 2 pi r squared. So let me put that down. So for the surface area of the structure, we have 2 pi r squared. If this is strange, please go and watch that video again. So this is that for the hemisphere. Then for the cone too has a circular base and it has a curved section, but we can't see the circular base because that's been covered with this hemisphere. So it's only going to be the curved surface area, which is pi rl. So let's factor out pi r. This will give you 2r plus l, right? If you factor out pi r from these two, so this will be 22/7 times, oh, we don't have the l yet, we don't have the l, this is the l. So we could say if this 14 meters is also 14 meters, right? Then we can say from Pythagoras, l squared is equal to h squared plus r squared, right? The h is 48, so that will be 48 squared plus the r is 14, so plus 14 squared. So 48 squared would give you 2304 plus 14 squared would give you 196. So 2304 plus 196, that will give you 2500. So the L squared is 2500, so that means the L will now be square root of 2500, and that will give you 50. Is it meters, centimeters, meters? So 50 meters. So substitute 22/7 times the R is 14, in brackets 2 times 14 plus 50, right? So 22 times 2 is 44, multiplying 2 times 14 is 28 plus 50. So this is 44 times 78. 44 times 78 would give you 3432 meters squared. So correct to 3 significant figures, this significant figure 1, significant figure 2, significant figure 3. So if I scroll down, this is approximately, and you know, after the third guy, the next guy is not even up to 5, so you cannot carry over anything. So that by approximately 3430 meters squared. So 23SF. Always go back to the question and say, what is the question actually asking me to do? Let's see if the answer is correct. Great. So 3430 meters squared to 3 significant figures. Question 6 notes that the total surface area of a solid cylinder is 165 centimeters squared. If the base diameter is 7 centimeters, calculate its height. Take pi to 22/7. This is from June 2019. So what are we given? We're given total surface area to be 165 centimeters squared. We're given the diameter to be 7 centimeters. Therefore, we can say the radius, which is d/2, is 7/2, or 3.5 centimeters. Calculate its height. We're told pi is 22/7. So to find total surface area of a cylinder, we have pi r squared, so that will be 2 pi r squared, and then the curved surface area, which is 2 pi r each. So from here, if I factor out 2 pi r, just leave me with r plus h. So this 2 times 22/7 times our r is 7/2, open bracket 7 over 2 plus our h is, where's our h? Unknown, that we're trying to find, right? So plus h. All of this will cause 165. 7 cancel 7, 2 cancel 2. So I'll be left with 165 is equal to 2 in 22, that is 11 times 7, that's 77 plus 22h. If I open up the bracket, so 165 minus 77, that will give you 88. 88 is equal to 22h, and if I divide this by 22, our h is equal to 4 centimeter, and that's the answer to this. Let's see if we're correct. Great. Question says that the volume of a cylindrical tank 10 meter high is 385 meter cube. Find the diameter of the tank. Take pi to 20/7. This take from June 2018. So the volume is 385 meter cube. This is part of our given. The height is 10 meters. But also find the diameter, not radius. Take pi to be 22/7. So V is equal to pi r square h, right? And this is 385 is equal to 22/7 times r squared times 10, right? So if I cross multiply, this is 385 times 7 is equal to 220 r squared. If I divide both sides by 220, so that's 385 times 7 divided by 220, that will give you 12.25. so our r squared is 12.25. so if I take the square root of both sides, square root of 12.25, that will give you 3.5. so the r is 3.5 cent. Okay, it's not centimeters, actually meters. Meter, so 3.5 meters. Yeah, so this is our answer. No, yes, it cuts me because it is diameter, not radius. Diameter is 2r, which is 2 times 3.5, which is 7 meters. So our answer is 7 meters. Let's see if our answer is correct. That'll be option C. Great. Question 2 says that the surface area of a sphere is 792/7 centimeters squared. Find correct to the nearest whole number is volume. Take pi to 22/70 from June 2018. So the surface area of a sphere has been given to be 792/7 centimeters squared. So these are given. But also find the volume. And we're given pi to be 22/7. 792/7 is equal to 4 times 22/7 times r squared. So by the time we do this, you realize that this 7 here will cancel, this 7 here will cancel. You can try that out. So 792 will be equal to 88 r squared, and if I divide both sides by 88, 792 divided by 88, that will give you 9. So our r squared is equal to 9, and if I take the square root of both sides, our r is equal to 3 centimeter. So given that our volume for a sphere is 4/3 pi r cube, right? So this is 4/3 times 22/7 times 3 cube, right? So this is 4 times 22 times 3 cube is 27 divided by 21. So our volume is 113.143 centimeter cube. So it says correct to the nearest whole number. After this whole number, but next number is 1, so it's not carrying over anything. So that's approximately 113 centimeter cube to the nearest whole number. Let's see if our answer is correct. That will be option A. Correct. Question 19 says that water flows out of a pipe at a rate of 40 pi centimeter cube per second into an empty cylindrical container of base radius 4 centimeter. Find the height of the water in the container after 4 seconds. Take pi to 20/70 from June 2017. So the water flows at a rate of 40 pi centimeter cube per second. That means if you are writing our given, we will say that the flow rate, let's call the flow rate V. Okay, no, V is like volume, so let's call it F. So let's say flow rate is like 40 pi centimeter cube per second. So this is how much volume of water comes out of the pipe in 1 second. So the radius of the empty cylinder is 4 centimeter. This is how you find the height of the water after 4 seconds. So that means at t is equal to 4 seconds. So this is unknown, right? Great. So we know the volume that goes out of the pipe per second. So if 40 pi centimeter cube goes out of the pipe in 1 second, so how much volume will have come out in 4 seconds? So you just cross multiply, and you say this x, you say x is equal to 40 pi times 4, and that will give you 160 pi centimeter cube. So this is how much volume of water has entered into this empty cylindrical container. So we want to know, if this volume of water has entered, how high did that water now rise? So we need the formula for volume to be pi r square h, right? So we want to know how high did that water rise when the volume of water inside was 160 pi centimeter cube. So this is 160 pi is equal to pi times the radius of the cylinder is given as 4. So that's times 4 squared, then times h. So this is 160 pi is equal to 16 pi h. If you divide both sides by 16 pi, so if I divide this by 16 pi and divide this one by 16 pi, you see that our h is equal to 10 centimeter. Simple and short. Let's see if answer is correct. That will be option A. Great. Question 2 says that the dimensions of a water tank are 13 centimeter, 10 centimeter, and 70 centimeter. If it is half filled with water, calculate the volume of water in liters. This is taken from June 2017. So yeah, we're given the breadth, the width, and the length of the tank. Let's say the tank is a cuboid, right? Then if it is half filled with water, calculate the volume of water in liters. So we know that the volume will just be length times width times height, right? So that will be 70 times 13 times 10. So 70 times 13 times 10, that will give you 9,100 centimeter cube. So 9,100 centimeter cube. Now said if it is half filled, so this is like the volume when it is full. So at half, let's say at half capacity, that will be 9,100 divided by 2, and that will give you 4,550 centimeter cube. But we know that 1,000 centimeter cube is 1 liter, right? So this is 1 water, so 4,550 centimeter cube will be x liters. So if I cross multiply, because this will give us 1,000 x is equal to 4,550, and if I divide both sides by 1,000, and that will give you your x to be 4.55 liters. So basically this is the volume of water at half capacity. Let's see if we're correct. That will be option A. Great. Question 1 says that if the total surface area of a solid hemisphere is equal to its volume, find its radius. This is taken from June 2017. So for a solid hemisphere, total surface area, I mean, you can see the bowl, you see the bowl and you see like the circular surface, right? So for the bowl, we already agreed that that will be what? Great. So 2 pi r squared, right? Then plus the circular top, that will be pi r squared. If you add these two together, that will give you 3 pi r squared. So this is the total surface area of a solid hemisphere, half. Then for the volume, what is the volume of an hemisphere? Can you remember that? Great. So 2 over 3 pi r cube. So they said if this guy is equal to this guy, what is the radius? Let's say if 3 pi r squared is equal to 2 over 3 pi r cube, what is r? If I divide both sides by pi r squared first, This will cancel this, it will leave one of the r, this will cancel this. So what I will have here will be 3 is equal to 2 over 3r, right? And if I cross multiply, that will be 3 times 3 is equal to 2r, 9 is equal to 2r, and if I divide both sides by 2, r is equal to 4.5. yeah, 4.5. So is it in centimeter or what? So we don't know, right? But I would adopt centimeter, so that is 4.5 centimeter. Let's see what the options will give us. Yeah, so we can say 4.5 centimeter, and that will be option B. Great. Question 2 says that the curved surface area of a cylinder 5 centimeter high is 110 centimeter squared. Find the radius of its base. Take pi to 22 over 7 from June 2016. So what are we given? We're told that the height of the cylinder is 5 centimeter. We're told that the curved surface area of the cylinder is 110 centimeter squared. We're told to find the radius of the base, and we're told to take pi to be 22 over 7. So for the curved surface area of a cylinder, that will be 2 pi rh. So if I substitute, that will be 110 is equal to 2 times 22 over 7 times r times the h is 5. So let's simplify this. That will be 2 times 22 times 5 divided by 7. That will give you 110 is equal to 220 over 7r. Right, so if I cross multiply, that will be 220r is equal to 110 times 7. And if I divide both sides by 220, this will go, this will go, this will go 1, this will go 2. You see that your r is 3.5 centimeter. Let's see if answer is correct. That will be option B. Great. Question 23 says that the volume of a pyramid with height 15 centimeter is 90 centimeter cube. If its base is a rectangle with dimension x centimeter by 6 centimeter, find the value of x. This is from June 2016. So for this kind of question, you can basically just draw out the pyramid, just do it like a rough sketch. You know that this is the rectangular base, and it's going to be, I mean, maybe something joining, right? I mean, just something. So what are we given? We're told that the volume is 90 centimeter cube. We're told that the height is 15 centimeter. We're told that the base is rectangle, so we can say the length is x centimeter, and then the breadth is 6 centimeter. Now for a pyramid, whenever I say pyramid, remember, whenever I say something like this, just know 1/3. So V is 1 over 3 base area times height. So the volume we're told is 90, 1 over 3 times the base area, because the rectangle, that is length times breadth. That will be x times 6, which will give you 6x, right? Times the h is 15, so that's times 15. So 3a1, 3a5. So you can say 90 is equal to 6 times 5 is 30. That will be 30x. And if I divide both sides by 30, my x is going to be 3. Let's see if our answer is correct. That will be option A. Great. Question 24 says that a sphere of radius r centimeter has the same volume as a cylinder of radius 3 centimeter and height 4 centimeter. Find the value of r. This is from June 2016. You can pause the video, get the question very well, try it yourself, and then play when you are done. So what are we given? We are given a sphere, and we are given a cylinder. For the sphere, the radius is r centimeter, and it says it has the same volume. So the volume here is the volume here. The radius of this one is 3 centimeter, and the height is 4 centimeter. So I thought to find the value of r. Great. So for the cylinder, we know that the volume is pi r square h, right? So that will be 22 over 7 times the r is 3, so that's 3 squared times the h is 4. So permit me to just leave it as pi, because I mean the sphere also has pi, so that will not make things hard. So that will be 9 times 4. That will give you 36 pi centimeter cube. That's for the volume of the cylinder. Since that's the same volume as the sphere, for the volume of a sphere, that will give you what? 4 over 3 pi r cube. So let's, I mean, they share the same volume, so that I could say 36 pi is equal to 4 over 3 pi r cube, right? And I can divide both sides by pi. Pi will cancel pi, pi will cancel pi. And what will be left to be 36 is equal to 4 over 3 r cube. And if I cross multiply, that will give you 4r cube is equal to 36 times 3. 36 times 3 will give you 108. So that's 108. And if I divide 108 by 4, that will give you 27. So if I divide both sides by 4, your r cube is equal to 27. And if I take the cube roots of both sides, right, that will be cube root of r cube is equal to cube root of 27. You can see that your r is just 3 centimeter. Let's see if we're correct. That will be option C. Great. Question 12 says that a cylinder tin 7 centimeter high is closed at one end. If its total surface area is 462 centimeters squared, calculate its radius. And told you to take pi to 22/7. This is from June 2016. To solve this, what are we given? We're told that the height of the cylinder is 7 centimeters, so the h is 7 centimeters. It's closed at one end, so that means the other end is open, right? And we're told that total surface area is 462 centimeters squared. We're told to find the radius if pi is 22/7. So for a cylinder that is closed at one end, that means that from the pi r square, there's only one of them that will hold. So in that case, our CSA will not be 2 pi r squared, it will be pi r squared in this case because the top is open, plus the curved surface area of the cylinder. We have established that that is 2 pi r h. So if I factor out pi r from this guy, you'll be left with r plus 2h, right? So this 462 is equal to 22/7 times r open bracket r plus 2 times 7, right? So this 462 is equal to 22 r. Let me first resolve this. This is 14, right? So 22/7 r times r, that will give you 22/7 r squared plus 22r/7 times 14 would give you 44r, right? So what can we do? I don't want this 7 to be at the bottom, so I can multiply all through by 7. So 462 times 7 will give you 3234 is equal to 22r squared plus 44 times 7 will give you 308. So that's 308r. These are also very big values. So let me see if the smallest number here can divide 3234 and it's 303 divided by 22 will give me a whole number. So 3234 divided by 22, okay, and then 308 divided by 22. Great. So the book gave me numbers, so I can say if I divide this guy by 22, 3234 divided by 22 is 147. So 147 is equal to r squared plus 308 divided by 22 would give you 14. So plus 14r. So if I rearrange, that would be r squared plus 14r minus 147 is equal to 0. So let's see 147. What can we break 147 with? So let's say 3. I think 3 will go. 3 in 14 is 4. 2, 3 in 27 is 9. 7 is 49 is 7. And this is 1. So let's see. So look at this guy. If I join these two guys, 3 times 7 is 21, right? And 7. So if I say 21r and then minus 7r, right? So if I do 21 minus 7, that will give me 14. Great. And if I multiply it, that will give me minus 147, because I'm going to look for two values that if I multiply, it will give me minus 147 r squared. And if I had it to give me 14r, and we have our values here, so I'll just replace. That will be r squared plus 21r minus 7r minus 147 is equal to 0. We've treated things like this before. So what is common in the first two guys? R is common. R squared divided by r will give you r, plus 21r divided by r will give you 21. What's common in these two? Minus 7. Minus 7 divided by minus 7 will give you r, minus 147 divided by minus 7, that will give you plus 21 is equal to 0. Since I have the same thing here and have the same thing here, we are good. So our values is r minus 7 when we group, and r plus 21 is equal to 0. So if this is the case, r minus 7 is equal to 0, or r plus 21 is equal to 0. So here r is equal to 7 or r is equal to minus 21. And because our r can never be a negative value, I've seen a negative radius, so our r, you can say therefore our r is 7 centimeter. Let's see if our answer is correct. Great. Question says that the volume of a cone of height 3 centimeter is 38 half centimeter cube. Find the radius of its base. Take pi to 22/7 from June 2015. So what are we given? We're told that the volume V is, so this 38 times 2, that will give you 76 plus 1, that's 77 over 2 centimeter cube. And the height is 3 centimeter. I thought to find the radius. Okay, this 3. If the pi is 22/7. So note that our V is 1/3 pi r square h, right? That will be 1/3 times 22/7 times the r is unknown, so that will be r squared times the h is 3, right? And that will give me 77/2. So 3 will cancel 3. We have 77/2 is equal to 22 r squared all over 7. If I cross multiply, that will be 22 times 2, that will give you 44 r squared is equal to 77 times 7, that will give you 539. And if I divide both sides by 44, our r squared is 12.25. Now if I take square root of 12.25, that will give you what? 3.5. So therefore, well, let me just say, taking square root of both sides, our r is 3.5 centimeter. Let's see if my answer is correct. That will be option B. Great. Question 27 says that the dimension of a rectangular tank are 2 meter by 7 meter by 11 meter. If its volume is equal to that of a cylindrical tank of height 4 centimeter, calculate the base radius of the cylindrical tank and take pi to be 20/7 from June 2015. So what are we given? We're told for the rectangle and then for the cylinder. So let's separate. The L is 11 meters, the width is 7 meters, the h is 2 meters. It could be, I could have swapped one for another, but I don't care. For the cylindrical tank, the height is 4 meter. We're told to find the radius. We're told that pi is 22/7. So the volume of this rectangular stuff will be length times width times height, which will be 11 times 7 times 2. So 11 times 7 times 2 would give you 154. So 154 centimeter cube. And if the volume of the rectangular tank is equal to the volume of the cylindrical tank, that means that the volume of the cylinder, which is pi r square h, is 154 is equal to 22/7 times r squared times 4. Right, so let's simplify. So that 154 is equal to 88 r squared all over 7. And if I cross multiply, 154 times 7 is equal to 88 r squared. If I divide both sides by 88, 154 times 7 divided by 88, that gave me 12.25. So 12.25 is equal to r squared. So if I take the square roots of both sides, right, our r would equal to square root of 12.25, which will give your r to be 3.5 centimeter. Let's see if our answer is correct. That should be option C. Great. Question 20 says that a reservoir in the form of a cone mounted on a hemisphere is built such that the plane face of the hemisphere fits exactly to the base of the cone. This is very similar to what we've been doing before. And the height of the cone is 6 times the radius of its base. Illustrate this formation in a diagram, and if the volume of the reservoir is 333 1/3 pi meter cube, calculate, correct to the nearest whole number, the volume of the hemisphere and total surface area of the reservoir. Take pi to 22/7 from June 2015. So this is a diagram of what is going to represent is not so new, right? The height of the cone is 6 times radius. So this is the cone. You can see the height is 6r, and the radius of the base of the cone is also the same thing as the radius of the hemisphere. So we're good with this. But in this question, what are we given? So we're told that the height of the cone is 6r, the radius still remains the radius. The volume of the reservoir is 333 1/3 pi meter cube. That's something I'm saying 1000 over 3 pi meter cube. Always check, you can easily miss out this pi. Please be very careful. So now that that is done, we're trying to find the volume of the hemisphere and the total surface area of the reservoir. The volume of the reservoir would be the volume of the cone plus the volume of the hemisphere. Volume of cone is 1 over 3 pi r square h plus volume of reservoir is 2 over 3 pi r cube. If I factor out pi r square over 3 from this guy, that will give me, it will give me h, right? Then plus, what would this remain? 2r. Great. So this will be 1000 over 3 pi on substituting is equal to pi times r squared all over 3, open bracket, our h is 6r plus 2r. So if you divide both sides, so that this pi will go, this pi will go, this 3 will go, this 3 will go. You can try that out. So that will be 1000 is equal to r squared times 8r. 1000 is equal to 8r cube. If I divide both sides by 8, so 1000 divided by 8, that will give you 125. R cube is equal to 125, and if I take cube roots of both sides, our R would be equal to 5 centimeter. Now that we know this, we can find the volume of the hemisphere to be 2 over 3 pi r cube, and I'll give you 2 over 3 times 22 over 7 times 5 cube. So 2 over 3 times 22 over 7 times 5 raised to the power of 3. So that will give you 261.9046 centimeter. Is this centimeter or meter? Oh, so everything has been in meter. So I was wrong here. Let me correct this. This should not be 5 centimeter. This should be 5 meters, and this should not be in centimeter. So you need to be very careful of your units. So these 5 meters and these meter cube. But they said that we should correct to the nearest whole number. So this is approximately, the next value after the whole number is greater than 5, which is 9. So it's carry over 1. So that will be 262 meter cube to the nearest whole number. Great. In our step, we find total surface area of the reservoir. So total surface area of reservoir, that will be, by the time you look at this, so that will be the surface area of the hemisphere plus the curved surface area of the cone. We've established that already in many examples. So that will be the surface area of the hemisphere plus the curved surface area of the cone. So the surface area of the hemisphere, the formula is 2 pi r squared, great, plus curved surface area of the cone is, great, pi rl. Do we know the L? No, we don't. We know the h and we know the radius. We can find the L from that. So I could just bring this down and say this is what we have. This is 6r. So this 6r, which is same thing as saying 30 meters, right? And this guy here is r, which is 5 meters. So you could say from Pythagoras, the L squared will be equal to the h squared plus r squared, and that will be 30 squared plus 5 squared. That will be 900 plus 25. So that's the L squared, and that will be 925. So square root of 925, that will give you, let me just write it by say taking the square roots of both sides, your L would now give you 30.4138 meters. Now that I know that, if I simplify this, I could say factoring out pi r, this would be 2r plus L, right? So 22 over 7 times the r is 5, multiplying 2 times 5 plus 30.4138. So that's 22 over 7 times 5 times 10 plus 30.4138. So this is 40.4138. So this 22 times 5 divided by 7 times 40.4138. That will give you 635.074 meters squared. So approximately 635 meters squared to the nearest whole number, because the next number after the whole number is less than 5. Let's see if our answers are correct. So you see a diagram here, 262 and 635 meters squared to the nearest whole number. Remember, all of them are in meter. So if you have centimeter somewhere, while you might get the answer for the steps, you might miss the answer for the units. So you have to be very careful. Question 9 says that the volume of a cube is 512 centimeter cube. Find the length of its size from June 2014. So for a cube, the volume of a cube is L cube. And we're told this is 512 is equal to L cube. So if I take the cube roots of both sides, that will be cube roots of 512 is equal to cube roots of L cube. So what's our L? Cube root of 512 is 8. So the length of each of the sides is 8 centimeter. Let's see if we're correct. Great, option C. And the last question says that the radii of the base of two cylindrical tins P and Q are R and 2R respectively. If the water level in P is 10 centimeter high, what would be the height of the same quantity of water in Q? Taken from June 2014. So we have rectangles P and rectangles Q. Radius is R, radius is 2R. The water level H in P is 10 centimeter, and they have the same quantity of water, so that means they have the same volume. So the volume of this guy is pi r square H, and that will be pi r squared times 10, which will be 10 pi r square, right? The volume of water in this guy V is pi r square H2, so this will be pi open bracket 2r all squared multiplying H. This will be 4 pi r square H, right? And they said that these guys, they have the same volume of water, so that means the volume here is the same volume here. So I could say V of P is equal to V of Q, and that will be 10 pi r square is equal to 4 pi r square H. If I divide both sides by 4 pi r square, 4 pi r squared, this will cancel this, this will cancel this. Our H is 2.5. So 2.5 meters. That's the quantity of water in Q. Let's see if we're correct. That will be option A. Great. And with this, we've come to the end of total surface area and volume. If you've gone through all the videos and all of the questions that we have solved so far, and you understand the why, which is the most important thing, and the how, which is the second most important thing, you're going to get all questions. And it's very important that you don't also miss out on small things like units, and read the questions very, very, very well before you solve. It has been an interesting ride on this particular topic, and I'll see you guys in the next video. Bye for now.